So if you haven't already, make sure you print out or just look at this, hopefully print out this worksheet to help you so you can follow along. I'm going to do an example or two, and then I'm going to leave it up to you to try to continue to work on this and finish this packet along with some book problems. Okay, so from the last video we talked about finding the area under the curves and approximating it, right? And we're going to do more with that on this one, using those left hand and right hand approximation methods, the trapezoid, and then a new one called MRAM, which uses the midpoint. So now instead of having intervals, you're going to have equations. So that's the big difference, but otherwise it's going to be pretty much the same as what we did last time. Okay, so if I'm looking at this, so here's my interval, 0 to 4 for this equation. And these ones I gave you the graphs. There's going to be some that I ask you to do that the graphs aren't given. You don't have to make the graph, but it does help us to visualize this, okay? So I'm going to do part A in pencil here, right? I'm going to use a different color for each part. Okay, so I'm between 0 and 4. Okay, now it doesn't tell me the length of the subintervals, but it does tell me the interval is between 0 and 4. So if I do 4 minus 0, that tells me that's 4. That's the change in x. Okay, and each interval, actually I shouldn't say delta x. Okay, that's the change in x, right, for the entire thing, but I want there to be 4 subintervals. So I'm going to take that, I'm going to divide by 4. And that gives me the change in x. So each interval length is going to be 1 for this. Okay, so I'm going to take my straight edge here. Let's see what I have for straight edge. My coaster, the closest thing I have, no rulers here. Okay, and I'm going to make all my so this is how I make my it didn't tell me where to make my verticals on this one, so I have to figure out where the verticals are. So remember, to figure out delta x, you do the length of the interval divided by the number of subintervals. So these problems, when it's not like a chart form like last time, it's going to tell you how many subintervals, and it's always going to give you the x values you're going between. So in this case it was 0 to 4. In this one 0 to 3, so you would do 3 minus 0. If this was 1, then it would be 4 minus 1, it'd be 3. Right? If this was 1, it'd be 4 minus 1, so you'd have 3 divided by 4. And it'd be a little bit more annoying, the numbers. Typically when you're doing this, your x values that you're going to deal with are going to come out to be nice numbers. Okay, so that gives us the length of each subinterval. Okay, now remember, this is LRAM, and LRAM uses the left endpoint. So if I'm looking at this first interval, that's 0 to 1. Here's my first interval. Okay, all right, and that first interval, the left endpoint is right here. Okay, now notice the x value there is 0. Now I can tell from the graph it's 10, but really, on some of these you're not going to be able to tell from the graph, so you always you think about what the x value is. So the left, it's between 0 and 1. The left point is 0, so I'll plug that into the function. I'll get 10. Okay? All right, f of 0 plus 10 is 10. Okay? So that tells me the height here is 10. All right? So it's a height of 10. It's a width of 1. Okay, remember, this is the height times the change in x. I'm doing the area of a rectangle. So the first one has an area of 10. Okay? Let's see, the second interval, that goes between 1 and 2. If I'm using the left endpoint has an x value of 1. The left endpoint in the interval is 1, so I'm going to plug that in. Right? Okay? If I plug in 1, all right, plug it in right here, or you look at my graph, but if I plug it in, I get negative 2 plus 10, I get 8. So that's my height. These are all my heights that I'm going to get here. All right? And remember, we take the heights and we're going to multiply by delta x. So that's why I multiplied by 1 for the first, and then I'm going to do 1 for the second. Okay? Notice that the intervals in this length, subintervals, are equal length, and that's because it told me. It told me it's equal length. And these ones, unless it tells you otherwise, always make them equal length. All right? It's easier to do. Okay? The next subinterval goes from 2 to 3. So if I'm doing the left endpoint is 2, right? Between 2 and 3, the left endpoint is 2, so I plug in 2. All right, negative 2 times 2 is negative 4, plus 10 is 6. That's the height of this next one. Oh, I forgot to draw the last one in. That's the height of this next one. Its width is 1, so it's an area of 6. Okay, let's see. The last subinterval, right, here's what it would look like using my left endpoint. Notice that's between 3 and 4, so I'm using 3 because that's the x value that's on the left. Negative 6 plus 10, that's 4. Right, that's my height. The width of it's still 1, so it's 4. I add all those together. And let's see, 10, 28. Okay? So there's my approximation using the left endpoint approximation. Okay. Now if I go to right, think about the first subinterval between 0 and 1. What's on the right? Oh, 1 is on the right. Look at I wrote 0 to 1, so 1 is on the right. So the first is going to be 1. Right? There's going to be my rectangle for it. Okay. We already figured out what 1 was. It had a value of 8. That's the height for this. Its width is 1. So the first one has an area of 8. For the subinterval between 1 and 2, if we're doing the right endpoint has an x value of 2. So we're doing f of 2. Here's where that is. F of 2, we already know. We could plug it in again, but we already know from this one that f of 2 is 6. The width of the rectangle is 1, so it has an area of 6. The next subinterval is between 2 and 3. The right x value is 3. F of 3, we already know that that's 4. That's the height. The width is 1. The last subinterval, right? We're using 4 because that's the right point. F of 4. If I plug in, we didn't do that before, so I'm actually going to have to plug it in. So negative 2 times 4 is negative 8, plus 2 is 2. Width of the rectangle is 1, so it has an area of 2. So if I do the right endpoint approximation, I get that it's 20. And there's no units here, so let's leave that. Okay? So I'm still making those rectangles like I did before. The difference was I actually have to figure out what the y values are, unlike what I had before. Okay? I'm actually going to skip down and do trapezoids, because remember we talked about that left and right are the average of those two. So my trapezoid there is going to be, let's see, let me grab another color here. Okay, so that's going to be 24, because remember it's 20 and 28 averaged out is 24. So trapezoid is really easy if you've just done L and RRAM. Okay, so most of the time I don't really write out trapezoids. I've already done LRAM and RRAM, and I just have to do the average of those two. I feel like it's easier to do the rectangles, so I just do that myself. Okay, now let's do midpoint. So for the midpoint, look at the interval between 0 and 1. What's the midpoint of the x value? It's 0.5 or half. Okay, so for MRAM, that's midpoint of the x's. Okay, MRAM, use the midpoint of the x's. So that's why between 0 and 1, the midpoint's 1/2. I'm going to plug that into my function. Okay, this one's not too bad. The midpoint, if I plug in 1/2, negative 2 times 1/2 is negative 1, plus 10 is 9. Okay, so this rectangle would be right about here. Okay, and so there would be my rectangle. Now this is nicer because the midpoint, because you're like kind of depending on your curves for yourself. You can say, oh, you know, there's some above, some below. This is kind of going right in the middle. That's my height. Again, multiply by the width, so that's 9. Okay. For this next interval between 1 and 2, well, between 1 and 2, what's the midpoint? 1.5. Okay. So for intervals 0 to 1, I use 1/2 because that's the midpoint of 0 and 1. For the interval of 1 to 2, I use 1/2. So I'll plug that in. 7's my height. My width is 1. So use 7. Okay. Next, and so that would be like right here, and that would be my rectangle there. For the interval between 2 and 3. Between 2 and 3, what's the midpoint Oh, it's 2.5. Okay, we're doing the midpoint between the ends here, right? It's not the y values. We're looking at this, getting use the midpoint of the x values, right? 2.5. Plug in 2.5 times 2 is 5, right? Negative 5 plus 10 is 5. 5 is the height, 1 is the width, area is 5. Same thing happens between 3 and 4, right? Halfway between 3 and 4 is 3.5. Plug it in. I get a y value of 3. Multiply it by 1 because that's the height, that's the width of it, so the area is 3. Add those all together. 10, 19, 24. Okay. You can see in this case the MRAM and the TRAM were equal to each other, and that's only because it's a straight line. Okay. It doesn't happen very often, but it can happen. Okay. So let's go to example 2 here. Okay. So it's basically the same thing, new equation, right? So what would be best is for you to hit the pause button, watch the actually I'm gonna stop the video here, right? And then I'm gonna make a second video. So give this one a try, and then watch the next video.